Welcome to aminacademy.com. In engineering mechanics, let us discuss about indirect impact of two bodies, some introduction. Look at this figure. The two bodies before impact are not moving along the line of impact. The collision is called the indirect or oblique impact as shown in figure. Here, these two cars collide each other not with the straight line of impact, line of action of impact, so it has some angles between them. Look at this figure. Two bodies impact each other. This is a direction of motion before impact of two bodies. This direction of motion after impact. This is a line of impact. Now let us do further. Your body 1, body 2, mass m1. Here mass of the body 2 is m2. u1 initial velocity. Initial velocity of the first body is u1. Here initial velocity of the second body is u2. Here angle with which the initial velocity of the first body make with the line of impact. Angle with line of impact. That means angle with initial velocity of the body makes with the line of impact. Angle with the line of impact of first body is alpha 1. Here the alpha 2. Final velocity v1 of the first body, final velocity is v2. Then angle with which the final velocity of the first body met with line of impact. Angle with line of impact of first body is theta 1, here theta 2. Angle with line of impact, that means after impact, this theta 1, here theta 2. Little consideration will show that the component of u1, u2, v1, v2 along the line of impact will cause the direct impact, and all the relation for the direct impact will withhold good for oblique impact also. Here this initial velocity make angle alpha 1 with the line of action, here alpha 2 with line of this action, have the component along the line of action is u1 cos alpha 1. Here initial velocity, component of initial velocity, component of initial is u1 cos alpha 1, here u2 cos alpha 2. Same for final velocity, that is component of final velocity of the first body, v1 cos theta 1, v2 cos theta 2. Now, law of conservation of momentum. Law of conservation of momentum is equal initial momentum along the line of impact equal total final momentum along the line of impact. That is m1 u1 cos alpha 1 plus for the first body. The second body is m2 u2 cos alpha 2, which is equal m1 v1 cos theta 1 plus m2 v2 cos theta 2. Next, Newton's law of collision by Newton's law of collision of elastic bodies. We have v2 final velocity after impact of the second body, v2 cos theta 2 minus v1, that is for first body, v1 cos theta 1 is equal a times u1 cos alpha 1 minus u2 cos alpha 2. By using this two expression, we can solve the problems. Where E equal coefficient of restitution, where E equal coefficient of restitution of the system. We have done. Please subscribe our YouTube channel.